Here is the graph that we just drew earlier with the slope of 0.5. If you look at this, and again, if I took away the dots, kind of blurry rise, and don't look at the blue dots that are the data points, you can't tell that there's a seam anywhere, right? It looks like just some guy drawing a line and getting this nice smooth graph. What it's actually made up of, though, are 3 cubic functions. This red line here is on the first interval. It's what we use from here, and actually it sort of defaults to further on the left. But we use it all the way up to here. And then it does something that I don't want. It shoots off towards infinity. So we don't use that part, actually. Instead, we pass it off like a baton and say, OK, at that point, we're going to hand the baton off to the light blue line, cyan line, if you like, which just happens, or is carefully designed to, come down and have the same slope, same concavity at that transition point. And then we use the blue line on that interval. So you can't see a seam when they're put together, but there actually are 3 different cubic functions being plotted as you go through this. We just use one of them on one specific one on each interval. That's how we get the whole thing. So it looks like a mess when you actually show all the graphs at once, but the product, carefully joined at the breaks, looks seamless, very smooth. So it's quite an elegant solution, actually. There's about the 60s. Yeah, it's basically when we started getting computers that could do some of these calculations in a meaningful time frame. 60s, 70s, there's a real rush into this kind of technology. It's quite, the math behind it's quite elegant, too. All right. Just as one quick last note about using the spline function, I did it in 2 different ways. Yeah, that's fine. This one here is the way I would usually do it in practice, because it's got the nice combination of find the spline, here's your spline, PP, all the information about it, and then use that PP with some new x values to generate a graph. MATLAB does have a shortcut, though. If you look at the help menu for the spline function, sometimes you just want a graph. And we're using this one here, and you can tell the difference in the outputs. The one we're using has PP on the left-hand side to indicate I'm getting some breaks and coefficients and dimensions, stuff like that. But if I just wanted y values, I could use the one at the top, where I give it x and y, the data, and also at the same time the x where I want to plot stuff. And it turns out that can be a little bit of a shortcut if you want. We just don't need this part here. Actually, I'll comment both these guys out. This is where we go to our kiosk and say, I'd like a spline built on my x and y data points. And can you just skip the middleman? Don't give me the coefficients. I don't really care about them. But just figure out the y values are at this xx list. And we get the same output at the end of the day. So that's if you don't need to do any side calculations. If you don't need to look inside the box and see what the coefficients are, that one-liner will also do the same job of getting a plot out. But it has more inputs because you have to give it more information than just the raw data. You also have to tell it, well, where would I like you to plot this in a second? Or where would you like me to calculate the y values?